we're going to do some Module 11 extra practice problems again today. So we are up to number 6, and this is on page 579 in your book. Number 6 says, how many grams of calcium chloride would you have to add to 125 grams of water to make a solution with a concentration of 2.0 molality? So what we are looking for in number 6 is how many grams of calcium chloride. And another way, if you're trying to figure out a good way to set up these problems or to figure out your steps, identify what you are looking for, which we've been doing, but then you can also, we've done this before in the past, just jot down what you know, okay? So we know that the molality equals 2.0, and we know that the grams of water is, I forgot, 100? 125. And we know we have 125 grams of water. Okay, and then you want to think about what equations you know that will help you to get from molality and grams to grams of calcium chloride. Remember, whenever we have something, the grams of something, we can always convert to moles of that thing using the periodic table. So we also know, or we can figure out the moles of calcium chloride. Okay, so this is ringing a bell for me. I know that molality equals moles of the solute. So in this case, actually, I'm going to write moles of, ooh, that looks messy. Oh well. Moles of calcium chloride divided by the kilograms of the solvent, which is water. So divided by kilograms of H2O. Okay, and I know molality, and I know kilograms of water because I have the grams of water. So I'm going to solve for moles of CaCl2. So we're going to rearrange our equation here. So the moles of CaCl2 would be equal to molality times kilograms of water. And then we can plug them in. So the molality is 2.0, and the kilograms of water would be 0.125 kilograms of water. And so the moles of CaCl2 would equal 0.25 moles of CaCl2. Okay, and now we just have to convert from moles of CaCl2 to grams of CaCl2. So we will put it in the factor label method, 0.25 moles of CaCl2. We're going to multiply it by the ratio of moles of CaCl2 on the bottom to grams of CaCl2 on the top. And if I look in the periodic table, 1 mole of CaCl2 would be 40.1 for the calcium, and then 35.5 times 2 for the chlorine, because there are 2 chlorines in CaCl2. So if I add those up, I get 111.1 grams of CaCl2 in every mole of CaCl2. Then with my calculator, I would do 0.25 times 111.1, and I would reach 28 grams of CaCl2. All right, and that is how you do number 6. Moving on to number 7. Number 7 says, if you wanted to protect water from freezing, which compound would accomplish this best? Calcium phosphate, aluminum nitrate, or sodium chloride? Assume that the molality of the solution is the same in each case. All right, so number 7 is asking us basically which of those compounds, when you add it to water, will lower the freezing point of water the most. Because if you want to protect water from freezing, you don't want it to freeze. And so you want the freezing point to be as low as possible so that those higher temperatures will not freeze water, okay? So which one of those three compounds would lower the freezing point the most? Let's remember our formula, or our equation for the difference in temperature for freezing point depression. The difference in temperature equals negative I times the constant Kf, which is the freezing point depression constant for water, in this case water, water's our solvent, times the molality, the concentration of what you are adding to the water, okay? So the molality, it said, for each of the compounds is the same. The Kf, the freezing point constant for water, is going to be the same. So the only thing that's changing between the different compounds is I. So in order to change the temperature the most, to lower the temperature the most, we want I to be as big as possible. I, remember, stands for how many ions the compound will split into when it is dissolved in water. So the choices are Ca3PO4 or let me see, AlNO3 or NaCl. Okay, calcium phosphate will split into 3 calcium ions, 3 Ca+ ions, and 2 phosphate ions, for a total of 1, 2, 3, 4, 5 ions. So I would equal 5 for that compound. For aluminum nitrate, there would be 1 aluminum, 1 Al3+, and there'd be 3 nitrate ions, 3 nitrate ions, for a total of I equals 4. For sodium chloride, it will separate into just sodium and chloride, so I would equal 2. So in order to change the temperature, to lower the temperature the most, to lower the freezing point the most for water, we would want to use calcium phosphate. So that would be your answer. I hope that makes sense. And lastly, we will do number 8 together in this video. Let me erase this. All right, got that erased. Moving on to number 8. Number 8 says, what is the freezing point of a solution that is made by dissolving 10 grams of potassium fluoride in 100 grams of water? So now we're going to use that freezing point depression equation. So for number 8, we're going to use delta T equals negative I times Kf, which is going to be given to you on the test or at on this page in your book. It's at the very top. That's a constant. Kf is a constant, times the molality, or the concentration of what you're dissolving in how much water. So for number 9, we had the compound was potassium fluoride, right? Is that right? Number 8? Yes, potassium fluoride. So this is going to split into 2 ions. It's going to split into K+ ions and F- ions. So I will equal 2. All right, Kf is given to us at the top of the page. It's 1.86 degrees Celsius per molality. So now we just have to figure out molality. Molality equals moles of Kf divided by kilograms of water in this case. All right, so how many moles of potassium fluoride do we have? Well, we know how many grams we have. We have 10 grams. So we got to convert that to moles. 10.0 grams of Kf times this ratio, 1 mole of KF has how many grams of KF? Look in your periodic table, add the values for K and for F, and you would get, oops, look, I put the units in the wrong place, because remember I want my grams to cancel out, so grams has to be on the bottom. That's a good little check right there. For every 1 mole of KF, I would have 58.1 grams of KF. So I'm going to do 10 divided by 58.1, and I will get 0.172 moles of KF. So now I can figure out what the molality would be. 0.172 moles of KF divided by how many kilograms of water in the problem? 100 grams equals 0.1000 kilograms of H2O. So that would equal 1.72 molality. Okay, so now we're going to plug all of these values into our equation. Delta T equals negative I, which is negative 2, times KF is 1.86 degrees Celsius per molality, times the molality is 1.72 molality. If you put that into your calculator, you will get negative 6.40 degrees Celsius. Now, is that the answer? The answer asked us for the actual freezing point. The actual freezing point of water without adding anything is 0. So if we lower it to, if we subtract 6.40 from 0, we would indeed get negative 6.40 degrees Celsius. That would be the new freezing point. And that's how you solve for number 8.